Welcome to Pavithra Laptop Care. In today's session, we come to know after pressing the power button. After pressing the power button, what are the changes will happen in the motherboard? Okay. See, before pressing power button, the main point has to be noted. That is number one, RTC VCC. Once this voltage will generate through the cell, that time what we get, RTC RST, it's a reset signal hash, SRTC RST hash. This is also the secondary and this is primary reset signals. These two are the main most important signals. Once this happens, next what we will get? We will get 19 volts. Okay, the all high-low MOSFET it will go, and LCD section, a main fuse will be there. There also it will go, LCD section, EDP section, and next this one, using this 3VL and 5VL we will get all appropriate signals. That 3VL carryable signals we will get. Okay, on and off LED, these are the main signals. Okay, after that keyboard will reset, EC RST. This is the second reset. First reset is this one. This, if we consider these both are one, then second reset will be ECRST. So after that, after this, what are the changes will happen? Now the next changes, the number one changes, EC will release EC on as a output signal. Okay, this is the first signal from the IO once you press the power button. Simultaneously, second one is power button out to PCH as a output signal. Next, sus acknowledgement hash. This one goes to PCH, asking the suspend related signals, because here everything is okay, we need suspend related voltage, but before this one more reset should be there, that one called KBRST. If keyboard is ready, then KBRST signal will start. Next, the fourth one, after this it receives, once these all are okay, the KB reset also over, then PCH will release what is that? Sus warn signal, and then immediately it will release suspend related voltages, S5 hash, S4 hash, S3 hash. Okay, these are the most important points. So now onwards you need to give more concentration on each and every points. Okay, so after pressing the power button, EC will release EC on signal, power button out, sus acknowledgement, and keyboard reset. Okay, according to this signal, the PCH first it will give the warn signal before after resetting this. So once it receives the acknowledgement, then sus warn signal it will send, PCH will send. After that everything is good, then the suspend disable mode it will send. If it enables, so what are the things will happen? It cuts the core supply in case these all are enabled. Okay, cut the core supply, and memory RAM section also it will disconnect. It will disconnect this both if this supply is enabled. So that's why it should be in disable mode. to disable this, here 3.3 volts should be there for S5, S4 and S3. Okay, now you got my point, right? Once we get the suspend related voltage, then all section will active till S0 section. Okay, so we will discuss one by one. If I tell more, so you will get confused definitely. Now the first part is, what is that? EC on. Once we receive this voltage, what it does, that we need to understand. This is enable signal to what? 3 volts always and 5 volts always. It means now when you press the power button, now this enable signal goes to this section. Means now it's a dual IC, dual phase, that is step down IC, 3-5 step down IC will receive the enable signal and will generate 3 volts always and 5 volts always. See here the IO releasing the EC on pin number 112. Okay, here is the pin number 112. It will come to where, see this section, and here enable 5 volts 3 volts, it renamed as enable 5 volts 3 volts, then it separated enable 3 volts, enable 5 volts. Okay, here what it will do, see this is the this is IC 3 volts 5 volts section. Here enable 1 and enable 2. Enable 1 is one phase and enable 2 is second phase. See, in case enable 1 is active, here actually previously we got 3 volts and 5 volts LDO, right? It means this IC receives the supply from here 19 volts and release the LDO voltages, and after that once it receives enable 5V, then enable 1, boot 1, upper gate 1, lower gate 1 and finally phase 1 will active. See, once enable starts, internally boot 1 will start. Okay, this is the driver for upper and lower gate pins. Once this starts, it will give the supply to upper and lower gates. Then here is the dual MOSFET, high-low MOSFETs. Here once 19 volts come to the drain to the higher MOSFET, then here function will start. So phase will generate and 5 volts VALP will generate. Similarly, here enable 2 is combined, what is that? Boot 2, upper gate 2 and lower gate 2. Once enable 2 will generate, then immediately what it will do, boot 2 will generate internally. Okay, this is the driver source to the input to upper and lower gate 2. Okay, once supply gives to upper and lower, then it will connect to dual MOSFET. One more dual MOSFET is here. So once it receives the drain voltage from the 19 volt supply, then it will start the action. What is that? Step down buck converter, 3 volts always it will generate through this coil. Here till here you will get the signals. Okay, up and down multiple will be there. Finally the one similar signal, one single signal will come to input to the coil, and output completely straight line you will get, pure DC. Okay, this is the process once you get the EC on signal. See, now after releasing 3 volts 5 volts always, one more important point is this IC will release SPOK signal. This is the power good voltage or signal from this IC. See, now what we did, first IO released EC on signal once you press the power button. This is output to, means it's output from the IO and input to where 3 5 section. So it released 3 5 section enable, and then by this enable signal 3 volts always and 5 volts always we got. Not only this voltage, along with this what are the signals, those also we got. The pull up signals by 3 volts and 5 volts. 5 volts won't come pull up, usually only 3 volts will come. Okay, most of the signals we got. After this, and one more signal we got, SPOK. See, this is the most important point, SPOK. Here is the EC on is the first. After that, you will be thinking actually where is one more important signal, I didn't talk those things, right? So that is PCH, RSM, RST hash. See, this one will generate once this SPOK is generate. Okay, before that it won't generate, because this 5 volts and always volts IC will generate the power good PG. The power good is SPOK. This SPOK only goes to the PCH, RSM, RST. Through this SPOK, PCH, RSM, RST process will start. The 3 volts always, where it will go and what it will generate, that we will check one by one. The first process is it will carry the SPOK signal. Next, it will be input, supply input to the 2.5 volts IC, and it will carry the pull up resistor. Through the pull up resistor, it will carry the signal of this power good. What is that? PG underscore plus 2.5 V. Next, it will be the input to the PU1801 IC. This is 1.8 VSP voltage IC input. Here it is a pull up voltage for touchpad clock and touchpad data. In these logic circuits, see here 3 volts always is becoming 3 volts prime. Here PCH enable, once we get the PCH power enable signal, so here it will be on, and here there will be no voltage. This is the P channel MOSFET, and here 3 volts always is becoming 3 volts prime. The same 3 volts always is becoming 3 volts always DSW. This is most important voltage. Here the 3 volts always is input for this LAN IC. The output is LAN VDD underscore 3V3. Here is the power connector. Okay, here in this connector, the pin number 1 will be 3 volts always. Through this logic circuit, here 3 volts is converting as 3VSW LAN. See here, it's going to the input as V in 2 to this particular IC. But once we get the susp hash voltage, I mean signal, sorry, this one is for susp hash, correct. Susp hash signals, then it's converting as 3Vs, the most important signal or voltage. So that's it. 3 volts where it has gone, and what it converted, the DSW, and 3Vs prime voltages, LAN, touchpad, right, touchpad, and touchpad clock and data. These are the things we saw in today's class. In next class will be most important classes, so don't miss out anything. So slowly you have to observe all the things. Okay, we'll see in the next class. Thank you.